See, Standard 10th Maths, Chapter 4, Theoretical Geometry, Pythagoras Theorem. See, Pythagoras Theorem, the statement is, in a right angle triangle, see it is a right angle triangle here, in a right angle triangle, See, the side opposite to 90 degree is the hypotenuse. So, the square on the hypotenuse. The square on the hypotenuse is equal to the sum of the squares on the other two sides. See, let me repeat the statement. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. We'll start the proof. Given, first concept given, triangle ABC is a right angle triangle. That is, angle A is equal to 90 degree. Angle A is equal to 90 degree. It is a right angle triangle. Come to the proof part. To prove the square on the hypotenuse. Hypotenuse is BC. So BC is the hypotenuse. The square on the hypotenuse equal to sum of the squares of other two sides. Other two sides is AB and AC. So AB squared plus AC squared. AB squared plus AC squared equal to BC squared. So let us start the proof theorem. Before that, we'll do the construction. The construction part, I am doing the construction here. I draw a perpendicular line from A to the base. See, I do the construction. Draw AD perpendicular to BC. See, both the sides the angle is 90 degree. Draw AD perpendicular to BC. So in this case, the bigger triangle is a right angle triangle. It's divided into two smaller right angle triangle. So now we are going to compare the triangles. Bigger triangle with the smaller two triangles. First, let me compare triangle ABC with the smaller one, this side ADB and ADC. How to compare? See here, one is first part here, triangle ABC. So, we are going to see the other smaller triangle. How to look at the other triangle? In angle A, first letter is A. Angle A is 90 degree. So, which angle is 90 degree in the smaller triangle? 90 degree is D. So, write D. And then second letter is B. So, B is in bigger triangle. B here. The same angle B is in the smaller triangle. Angle B. And the remaining angle is C. So here the remaining letter is here A. We taken D, B and remaining letter is A. So these two triangle, see this angle is common. Angle B is common. In both the case angle B is common. common. And see here angle A and here angle D is 90 degree. In bigger triangle, angle A, and in smaller triangle, angle D is equal to 90. So write the remaining letters. B this side, C this side. This is equal to B this side and A this side. The same way, in the second part you take here bigger triangle ABC. First let me write bigger triangle ABC. With that you compare the other side smaller triangle. So in the bigger triangle, angle A is here 90. So which angle is 90 here? D. So D. So write the letter D first. Triangle D. A 90, so D is also 90. Which angle is common for this side? So in the bigger triangle, angle C, and here the bigger triangle, angle C. So in the place of C, I write the angle C. C, and here also you have C. So one more letter left here is here for you D, here A. Left here is A. So DAC. 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 So now we compare the angles of this triangle. See, C is common. Angle C is common here for these two triangles. And which angle is 90 here? A. And which angle is 90 here? D is equal to 90. So write the remaining letter on both the sides. This is B, A, C. And then here D, so A, D, C. So this is 90 degree. Okay. So what do you say about these two triangles? One bigger and one smaller. Here one bigger and one smaller. So these angles are, corresponding angles are equal. So these triangles are similar triangle. Is similar to triangle DBA. DBA. Triangle ABC is similar to triangle DAC. Similar to triangle DAC. Okay. Now let us take the corresponding sides. Corresponding sides. See, in the proving part we need AB. AB. So let me take in this triangle. Where is AB here? Here AB. AB. In the first triangle we have AB. So when I take here AB, the same first letter I will take first two letters here DB. So they are corresponding sides. Okay. So here AB means we need to get AB squared. So in the denominator, in the second triangle, we have to get DAB. So I write AB here. So second and third. Here and second and third is BC. BC. Same way, you take here AB I consider. Here you consider AC. Where do I get AC? The first and the third AC. AC. The same first and third letter you take. DC is equal to, here AC means in the denominator, here AC must get from the smaller triangle. See AC. Second and third. So here second and third is BC. BC. So now cross multiply. AB into AB, AB squared. DB into BC. DB into BC. AC into AC, AC squared is equal to DC into BC. So mark this as 1 and this is 2. So part 1, this is part 1 and this is part 2. In part 3, what I do? I add 1 and 2. Add 1 and 2. Add 1 and 2. So left side AB squared, AB squared. Here this is AC squared is equal to, right side is DB dot BC plus DC dot BC, DC dot BC, DB dot BC, and this is DC dot BC. So here BC is common. BC is common. So we will get here DB and remaining here DC. So BC, what is DB plus DC? DB plus DC. DB plus DC is BC. So into BC. BC into BC is equal to BC squared. So AB squared plus AC squared is equal to BC squared. This is that we want to prove this. So hence proved. So this is the Pythagoras theorem. So you must get the diagram first. From the diagram, you must understand the concept and you try to prove that. You no need to by heart this. So first you take the single letter angles and then corresponding sides you have to take. So thank you.